Hello, everybody, and welcome to our webinar around Tanzu Manage. I'm Oren Penso, and I'm a technical leader for emerging technologies in the modern application platform business unit in VMware. And we will go over the Manage pillar of the Tanzu portfolio in the next hour or so. Let me just share my screen for a second. Yep. Okay. So the Tanzu portfolio is all around a bunch of services, products, and technologies to simplify your application modernization in your own organization. So simplify the multi-cloud operation, bring the cloud-native architecture to your organization, ship the products that you're developing to production as fast as you can, and basically transform the dev and operations experience while handling that cloud-native application. Now, it's mostly around the way that you're developing your application and the way that you're shipping that code into production, but it's also around how do you manage that and create the underlaid platform to support that code and to move from idea to production as fast as you can. So the VMware Tanzu has three main pillars: the build, the run, and the manage. The run is all about how do you take Kubernetes as an orchestration layer, as an abstraction layer, and stretch it across any infrastructure provider. So basically using Kubernetes as an API layer with the same user experience and the same way of interacting across any infrastructure provider and any cloud. And then you have the build. How do you build your code on that? But we will focus today on the manage pillar. So we know our customers will use not just the on-premise environment, the data center environment, but also they're going to use different public clouds because they want to leverage unique capabilities from different clouds. So the manage pillar is all about how do you take that multi-cluster, multi-cloud, multi-team environment and basically get the consistency from the management, security, and any other aspect. And we will get to that in today's presentation. So containers and Kubernetes. Why containers and why Kubernetes? Because you can develop faster. The velocity of the versions will be faster. You can have consistency across different infrastructure providers. You will have better resource utilization because you're using containers, just like you had better utilization when you transition from physical servers to virtualization. And now also improve delivery. So in the Kubernetes adoption journey, we have different aspects of that Kubernetes landscape. But one thing is for sure, when you adopt Kubernetes, when you adopt cloud native architecture, and when you start developing that, you will have an explosion of entities in your environment. You will have a lot of different microservices, and those different parts will need to be connected, managed, secured, monitored, just like you're using virtual machines. And it's definitely something that you need to take in consideration when you're expanding to multi-cluster and multi-cloud. And I'm gonna refer to Q&A in the middle, so I can already see two questions about the build. So this session right now today is only about the manage pillar and the way that we are keeping the consistency of the operational and security aspect. And I will take that in consideration, and I will ask to create another session just about the build, where I can be more focused on that, the way that you're building your code and shipping that on Kubernetes. But that's in another session. Today, we will be more focused on the mission control and the way that we are managing multi-cluster, multi-cloud. So going back to the amount of entities that you will have in your organization, it's going to be also not just those microservices that you're creating and the Kubernetes clusters that you will have. As I said, most of our customers will eventually want to use specific capabilities from public clouds. And in that case, you will probably gonna to create the Kubernetes clusters on those clouds. Just because of the laws of physics, you won't be able to create Kubernetes cluster on premise that will consume some services in the cloud. So you will probably use those services of EKS, AKS, GKE, maybe others on that public cloud to be able to consume that unique capabilities. Now, in that case, the challenge is even greater because now that you have lots of different components and applications and lots of different clusters that you have, how do you still get that consistency and how do you manage everything under the same control plane? So one part that is another part that is challenging in that is also the cost and knowledge. To be able to manage those different Kubernetes clusters across different clouds, you need to enable your team to do that. You need to understand the architecture that is involved in that. You need to know the Kubernetes service that you're using. And there's a lot of different things that you will do different between different clouds. So when you want to create even a identity, and that's me trying to create identity on different Kubernetes clusters on different clouds, you will need to interact with different consoles, with different UIs, with different methods, and with different methodology, just to create your own environment identity and your own role to be able to log in into that cluster. Those different snowflakes reflects also to the operational side. So it's not just the identity, it's also the way that you are applying security policies, like pod security policies or network policies. It's also the lack of knowledge around conformancy. How do you know if your clusters is configured correctly or not? If someone changed something in one cluster, how do you know if that cluster is drifted away from the configuration that you decided to do for the rest of your organization? So as you can see, the challenge is real. When you have multiple Kubernetes clusters in multiple clouds or even in your own environment, there's a huge challenge in just managing those and keep consistency of everything. Now, I'm not even getting into the challenge of managing the Kubernetes itself. How do you provision Kubernetes clusters? How do you scale out? How do you upgrade the version? How do you do everything? And that's also a huge challenge of the lifecycle management, and I will address that as well. Okay, so VMware Tanzu Mission Control. Mission Control is our way to answer that challenge that I just elaborated on. It's our way to think about taking Kubernetes as an API layer that is abstracting the infrastructure and leveraging that Kubernetes layer to manage other Kubernetes clusters. Now, how do we do that? Kubernetes is the same across any infrastructure provider, right? It's not different. When you do kube control with an API of Kubernetes, you will do the same kube control for EKS, AKS, GKE, OpenShift 4, Tanzu Kubernetes Grid, and any other Kubernetes distribution. Now, that abstraction will also allows us to address those clusters in the same way. So I want to be extreme in the saying of I don't really care which kind of infrastructure you're using as long as it's conformant Kubernetes. Because if it's conformant Kubernetes, I can use kube control and I can manage those clusters. If we will take the example of the identity, that identity is represented in the Kubernetes side in two objects, role and role binding. So if I can inject those objects to Kubernetes with kube control create role binding, it's going to be the same across any infrastructure provider. And that's exactly is the magic behind the Tanzu Mission Control. We are leveraging Kubernetes and open source projects and toolsets to be able to interact with those clusters, no matter which infrastructure they are relied on. And it's more than that, because in Tanzu Mission Control, we also combined different hierarchies. So we can now share workspace and Kubernetes clusters between teams and inside teams. And we can increase the productivity of those teams working on a specific code or development cycle, because they now can have the same consistency of login, of policies, of registry. And I will show everything in I think in a nice demo, because I want to be more focused on showing you the technology than being focused on slides. Another important aspect, and I've said it in a couple of words, consistency and security. That's the most important part. you're transitioning into Kubernetes, and you can't see the slides. Okay, sorry, just a second. So that's a lot of slides that I've already been over. Can anyone confirm that you see my screen? Can anyone confirm or not that you can see my screen? If not, I will try to share again. No. Okay. Just a second. Yes, we can. Okay. So what you see now is the Tanzu mission control slide, hopefully. Yes, okay. So I'm sorry for the technical issue, but the most important part is to see the demo once I will bring the demo up. So I hope that will be visible. Yeah, okay. So Tanzu Mission Control has the capability to do two main things. One is provision cluster, and the second is attach a cluster. In those two cases, Tanzu Mission Control will have a lot of different capabilities and a lot of different plugins to other Tanzu related products. So when you attach a cluster to Tanzu Mission Control, you won't be able to manage the lifecycle management of that cluster, because if you're attaching a cluster, that's probably AKS, EKS, GKE, OpenShift, or something else that is being managed with other lifecycle management. But regardless of that lifecycle management aspect, you will be able to do everything else. So you will be able to manage the identity and access. You will be able to manage the security and compliance with policies. You will be able to check the conformancy and configuration and audit of that cluster. And you will be able to create data protection rules for that cluster. So you can back up and restore that cluster as long as it's a Kubernetes conformant cluster. Now you see four different plugins that is connected into Tanzu Mission Control and basically expand the control plane outside of the boundaries of operational aspects. One of them is Tanzu Observability. Tanzu Observability is our observability tool that can bring you a lot of insight around everything in your stack, from the physical hardware, virtualization, Kubernetes, and the application itself. And I will touch that in a nutshell when I will show the integration in the demo. I will get just from the Tanzu Mission Control, right click, bring me to a dashboard, and I will get the dashboard with all the insights around the cluster from Tanzu Observability. Tanzu Application Catalog is the way that we can consolidate and expose a curated, secured, open source projects that we are the one to curate the content. So one of the companies that we have acquired in the last 2 years was Bitnami. Bitnami is a company that is all around the open source projects, tool sets, and binaries. And Bitnami is also responsible for more than 300 open source projects that is being published to AWS catalog and Azure catalog and GCP catalog. So if you want to consume Redis in AWS catalog, that was packaged, curated, secured, and stable by Bitnami. So what we are doing with Tanzu Application Catalog is taking all of that force, all of those open source projects, and bring that internally to your own environment. So you can create an internal catalog where you're pulling everything from external source, our source, that is stable, curated, and secured. And you can also add to that Tanzu application catalog different internal binaries that you're developing and creating, and basically consolidate that under Tanzu Mission Control. Cloud Health is the way that you can get showback, chargeback, and just understand the cost of that workload that you're creating on each and every one of those clouds. And Tanzu Service Mesh is the second dimension of Tanzu Mission Control. So Tanzu Service Mesh is all about how do you connect all the workloads, encrypt the communication, understand what's going on inside. So it's leveraging the Istio Service Mesh underneath as the data plane, but it's connecting that connectivity layer across different Kubernetes clusters and across different objects. So that's Tanzu Service Mesh. Manage any cluster. So I've said that we basically have two different options inside Tanzu Mission Control. We have an option to provision clusters, and we have an option to attach a cluster. Now, the only thing that matters here is that the cluster must be conformant. And I will say conformancy a lot of times in the conversation, so let's stay with that for a second. Conformancy in Kubernetes is more than 250 parameters that the community decided that those are the best practice way to configure Kubernetes cluster. It also means that if you're interacting with a conformant Kubernetes clusters and you're changing a cloud, if in the second cloud that Kubernetes cluster is also conformant, you will have the same way of interaction. You will have the same way. You won't need to change anything in the interaction API layer, commands, and everything else. So that's why conformancy matters, especially when you go to a multi-cluster and multi-cloud environment. Now, Tanzu Mission Control also has a structure of clusters and workspaces, and I will get to that. A workspace is an application construct. If you're attaching your Kubernetes clusters or provisioning your Kubernetes clusters, we are now able to manage the entire stack of namespaces across all of those clusters. So you can aggregate multiple namespaces from multiple clusters, and then you can address that as an application construct and apply on that policies and other aspects. So you can address those objects either with an application construct or an infrastructure construct, and that's a Kubernetes cluster group. Let's keep going with the presentation because I really want to get into the demo. Two ways to provision cluster, either without availability or with availability. So when you provision a cluster, you can decide how many control planes will you have. And if you're deciding high availability, you can also decide in which availability zone that control plane will be. So when you provision a cluster, it's basically creating, in our case, I will show the connectivity to AWS as the IaaS. So it's going to create EC2's machines. It's going to create either one control plane if I'm doing single node, or it's going to create three control planes if I'm doing availability. And then I can decide which kind of availability zones I want to use in my AWS region. And that's basically provision clusters. Now, the way that it's working is with Cluster API. Cluster API is the lifecycle management engine from the community. And Cluster API is leveraging Kubernetes again to create and manage the lifecycle management on Kubernetes. It's inception mode. It's just creating, instead of creating a workload, it's creating a Kubernetes cluster. So it's basically applying a YAML file, a manifest. That manifest will declare a cluster, and then Kubernetes can manage that cluster just like it's managing any other workload. Why it's important? Because in that way, we can provision clusters to the infrastructure providers that we choose exactly in the same way. We are creating a manifest of the declaration of a cluster, and then we apply that on the Kubernetes management console or management point, and from there, it's going to create the clusters. There's different node pools that you can decide. Node pools are the nodes. So when you create a control plane, you can create either one or more. When you get to the configuration of the nodes, you can create as many as you want. Now you can also mix and match. So you can create different node pools with different sizes because you want to create some node pools that has more. The EC2 is the EC2 size is larger, or you can do that with the different, let's say, GPU resources or something like that. You can decide inside the Tanzu Mission Control, and you provision which kind of node and how many nodes you want in that Kubernetes cluster. When we get into the manage part of the Kubernetes clusters, to be able to attach a Kubernetes cluster, the only thing you need is to configure the name of the cluster and the cluster group that you want that cluster to be part of. Once you do that, you will get a URL with a kubectl API a command with a YAML file that basically gonna install the agents of Tanzu Mission Control on the cluster. Once it's installing that, the cluster is attached, and now you can do everything that I've said except of the lifecycle management on that cluster. And again, we will get into more details of what we can do and how we can do that in the demo. So let's talk a little bit about architecture or hierarchies. In the hierarchies, we have, as I said, two different hierarchies. One is more an application focus, that's the workspace, and one is more the cluster infrastructure construct. Now, in those two different concepts, in Kubernetes in general, there's two different policies or policies options that you can apply. You will apply policies that are in the context of an application on a namespace or on a workspace. And I can give you an example. If I want to apply an image registry policy, where I'm saying to my development team or my DevOps engineers team that they have to pull from specific registry, my local registry, and not from Docker IO, because there's a lot of vulnerabilities on that. That kind of policy is related into an application construct. It's related into a namespace, or in our case, a workspace. A workspace is a higher construct for a namespace. So you can aggregate multiple namespaces into a single workspace across different clusters, of course. From the other end, there's policies and there's constructs that is infrastructure driven. Let's say identity. When you give identity to someone, you will give that in a cluster level or a cluster group level. When you do pod security policies, when you do something that is restricting that workload of running inside that cluster, and you're doing that on a cluster level and not on a namespace level. And that's why we have two different hierarchies inside Tanzu Mission Control. And you can see the highest level is organization. You as a customer can decide that you will have different organizations as well. So you can create multiple organizations, multiple cluster groups, multiple workspaces, and basically structure that Tanzu Mission Control exactly like your own environment and your own organization. Let's talk a little bit about policies. So the kinds of policies that we have is identity and access, security policies, network policies, image registry policies, and namespaces and quotas. And I will go over that in the demo as well. Okay, so question is namespace and context are the same. So namespace has a context in Kubernetes. You can allow your users access to a specific namespace, but you're probably gonna do that firstly on the cluster level. So you will give access to the cluster, and then you can decide inside the cluster if they have access to all of the namespaces or not. So that's in a namespace level. Let's go over policies, and the first thing is the global policy. So what we did with policies, as I said, is we are separating the construct of a cluster and infrastructure than a workspace and a namespace. And it's easier to understand with personas. The platform operators will probably apply policies on an application construct, like image registry policy or network policy according to a label, or anything else that is application driven. And from the other end, the infrastructure manager or the infrastructure operator will apply a security context on a cluster level, and that is more security oriented or access or something like that. When you do the identity and access policies, just a second, sorry. Okay. So when you do the identity policies, you're basically allowing in the Tanzu mission control level access to your clusters according to different groups, cluster groups or not. And when you do that, it's just configuring that in a group level, and it's just getting into the cluster level underneath. So you can integrate that Tanzu mission control organization into a third-party identity provider that you have, and then actually decide with that integration which kind of a cluster gets which permission. And again, I will show that as part of the demo. Image registry policies will say for your developers if they can or can't push from a registry. So I can say you can push only from my internal harbor. You can't push from any Docker IO or something else. And network policy will say allow, deny a network to a specific pod or services, and according to labels or not. So it's really high-level security policies. It's not micro-segmentation, but it's the most common ground. So if you want to create something that is consistent across different clouds, you need basically to get a common ground between all of those clouds, and that's the common ground between all of them. So you can create either denial, allow all, or you can do that according to a specific label. And it doesn't really matter if that Kubernetes cluster is using which kind of CNI or which kind of underlay, it's going to work in the same way. Security policy leverages the pod security policy capabilities of Kubernetes, and it will allow you to stay consistent across your different Kubernetes clusters with different security aspects. Like, let's say you can decide that no workload should run as root. You can decide there's not going to be any escalation privilege. You can decide there's not going to be any mount of host paths, or your developers can't build any object of config map or secret, because that can be vulnerable and they can have something in there that eventually going to leak. So that's pod security policy, and one of the challenges in pod security policy is to manage that, to create and manage pod security policy. It's not easy. The objects are different and complex, so that's definitely something that we are creating that in a more accessible way with nice wizards, and I will show that again in the demo. Namespace quota policies, that's another namespace construct. The way that you can actually limit the amount of resources that you give to a specific development team according to either t-shirt size, out of the box sizes, or custom where you define the amount of CPU limits, memory limits, or CPU request and memory request that you want to allow to that. Now, everything, by the way, you can see that from the print screen, and everything in Tanzu Mission Control has a label selector. So you can do everything in a dynamic way. And regardless of that, Tanzu in general has the 3 golden rules. Everything in Tanzu has an API, a CLI, and a UI. So everything that I'm cluster inspections. Well, I've said several times conformancy, and I've stated what is conformancy. The way that you can check conformancy is with an open source project called Sonobuoy. Sonobuoy is basically taking that conformancy tests and run that against your Kubernetes cluster to understand if the cluster is configured correctly or not. Another important thing that Sonobuoy is doing is, because it's open source, a lot of people is creating a lot of different plugins to that Sonobuoy. So one of the plugins that is already around, and we are leveraging that, is the plugin for the CIS security inspection. So you can run a CIS benchmark across your Kubernetes clusters and then get back the results. And according to the result, you can decide what you need to do and how do you need to change that to basically be aligned with that CIS benchmark. Data protection. In data protection, we are leveraging the most common backup and restore mechanism in the community, and that's Velero. And the way that we are doing that is embedded inside Tanzu Mission Control. So we are configuring a user that will interact with one of my regions in AWS. I'm configuring an AWS S3 storage, basically to save that states. And then I'm just running that Velero job, or the Velero backup and restore backup mechanism on my clusters. Now, that Velero capability will be abstracted, of course, across any conformant Kubernetes cluster, but also it's going to be abstracted on the restore part. So if you want to lift and shift your Kubernetes cluster, you can back up one of them, let's say EKS, and restore that for AKS or GKE or anything else. And we also adding capabilities every other week. So every 2 weeks, there's a minor version of Tanzu Mission Control. In the new version that was out 2 weeks ago, we also added a scheduler, so you can decide if you want to do that in a recurring state, if you want to back up every week, every day, every month, or something that is custom for you. And I will go over that as well in my demo. And that's the demo time. I will give you 1 minute to ask questions on the Q&A before I'm getting into the demo. If anyone has something, and I will try to go over the question that was already in the Q&A to see if I've answered everything. Yes, the deck is, I think the deck will be shared with you as part of the session. Okay, so I don't see any other questions, so we can get into the demo. So if anyone just can confirm that you can see my screen with Tanzu Mission Control, any ping will be fine. Okay, cool. Okay, so that's Tanzu Mission Control, and at first glance you can see our different clusters that I'm managing right now. Now, another thing, important thing, housekeeping note: if it's too small, you can enlarge the screen on the demo to get a better visibility for that demo. So you can see a lot of different clusters that is inside of my Tanzu Mission Control. AWS ones, Google Cloud, Azure, and of course vSphere. All of those clusters is being managed. Part of them is being provisioned by Tanzu Mission Control. Part of them is being attached to Tanzu Mission Control. So let's take one that was already provisioned from that, and I will take that one, dev AWS Tanzu build service. And it's on AWS. It's healthy right now. You can see the version. It's 1.18.5. Could you make it full screen? It's not full screen like that. I hope that's okay. Text screen is very small. I don't know if I can do that larger than what I did right now. Try to enlarge the window that you see inside the platform as much as you can. So the version of that dev AWS cluster is 1.18.5, and I can see I have a bubble here that says upgrade available. The reason I'm getting that bubble is because that cluster was provisioned by Tanzu Mission Control. So if I will click on that cluster, those are the amount of operational perspective you can see just at first glance. So you can see it's installed on AWS, that's the version, it's in region EU West 1, there's one control plane, 4 nodes, 11 namespaces, the amount of pods, what's the total memory, CPUs, and you can see the allocation of the CPU and memory. You can see the health state of Kubernetes, so Kubernetes scheduler, Kube API, etcd, controller manager, and you can also see the extensions of Tanzu Mission Control being installed on that cluster. So you can see agent updater, you can see a gatekeeper, that's for policy, you can see policy sync, wavefront, that's Tanzu observability, and you will see inspection, so that's Sonobuoy, and data protection, that's Velero, and all of the different capabilities that I've said to leverage all of the capabilities that I've stated basically. Now you can see node pools. The label of node pools is here because I've provisioned that cluster from Tanzu Mission Control. If I will click that, I can see that I have a window where I can change my worker nodes. So I can just edit that and say that I want another one, save. That's going to resize the cluster. So it's going to go now to AWS. It will provision an EC2 instance, and then it's just going to attach that into the cluster as a node. And that's the node pools and the upgrade capability that you see here. Those are the two main functions that is part of the lifecycle management that is not in any other conformant Kubernetes cluster that is being attached. But regardless of that, anything else will look exactly the same. By the way, if I will go to the actions and upgrade, I will have the option to upgrade the cluster, and I can decide which kind of version I want to upgrade to. The latest one is 1.18.8, but I can upgrade to 1.18.6 if I want to in the meantime. Same goes for when you create a cluster. You don't have to create the latest and greatest. You can create one minor behind or two minor behinds. It really depends on you. You can see the worker nodes. So there's 4 worker nodes. There's going to be 5 in a second because we've just resized the cluster. The 4 nodes are healthy, and I can actually go to the nodes themselves and see those nodes, one control plane for workers. And if I will click on one of them, I will see the node information. So I can see what's the kernel version, what's the OS image, what's the container runtime environment that it's installed on. So container D is running the container right now. And what's the pod CIDR and a lot of other things. What's the allocated CPU memory per node? And that's important if you need to root cause analysis or something like that. And what's the node conditions? Network, memory, disk pressure, PID pressure, and if it's ready or not. Now you can also see pods that are running, and those are the pods that are running according to that node. So it's running on that node. Why it's important again? Because if you need to root cause analysis and you need to understand which pod is running or not running in a specific node, you can understand that just by correlating the pods and the node. Now I can see all the namespaces that is inside that Kubernetes cluster. You can see apps, concurs, build service, that's the Tanzu build service, Velero, that's the backup and restore. TMC is the namespace for TMC with all the different agents, and Tanzu observability for the observability aspects. I can hide Tanzu namespaces and system namespaces, and basically that will leave me with all the other components that I've installed on that namespace. I can also create a namespace from here. So let's do that in the cluster that we will actually gonna play with today, and that's a Tanzu Kubernetes grid cluster from security. So security test cluster. That cluster wasn't provisioned by Tanzu Mission Control, so there's no node pools, and there's not gonna be any way of managing the lifecycle management of that. Other than those 2 different things, everything is the same. So we can go now to namespaces, and I will hide the system in Tanzu namespaces, and I will create a new namespace. That namespace let's call it demo. I'm creating that in the security test cluster, and I can attach that into a workspace. So a workspace, as I said, that's a construct that will allow you to aggregate multiple namespaces. Let's put it on the default right now and create. So that's going to add that demo namespace in the workspace default. You can also see there's an Nginx one that was created by Tanzu Mission Control, and you can see it's part of that workspace. So it's being managed by Tanzu Mission Control. It's not something that someone else is configured. That's Tanzu Mission Control configuration. On workloads, you can see the different pods that are running. And if we will take one of them, let's take a daemon set, the Calico node. You will see the pods that are running, one for each cluster because it's one for each node, and that's the source YAML for that pod. And that's also something that you have visibility for, and that's all the YAML files that is configuring that workload. And in inspections, you will see inspections that are running conformant or CIS benchmark. If I will go back for my AWS TBS inspections, that's already been through a conformancy test. And if I will click on the results, I can see the result of that conformance inspection. So it was inspected for 275 parameters, and you can see all the parameters that is part of that inspection. So daemon set, pods, you can see the different special interest groups. So SIG storage, SIG API, SIG network, all of the different special interest group from the community that basically created that conformancy test. So that cluster has been over a conformancy test, and it's successful, so I know it's conformant. Another capability, except the inspection, is the data protection. So I can run a backup on my cluster. If I'm going to create a backup, I can decide if I'm creating the backup to the full cluster with just a namespace, or according to a label selector. If I'm doing that for the entire cluster, I can now decide on a schedule type, hourly, daily, weekly, monthly, or custom, or right now. Next, how much retention time I want for that backup. Next, and the name and new backup. Create. So that's gonna run now the backup. You can see I've already created one TBS backup, and I don't have any schedules, and I don't have any restores for now. So I didn't restore anything yet. But that's the Tanzu data protection, the Tanzu Mission Control data protection capability. Okay, let's go back to clusters. And we've been over the inspections and the namespaces. And I just want to show you briefly the way that you're creating a cluster. So if I will go to create a cluster, I need to decide which account credential I'm using. In my case, I'm interacting with AWS. I'm going to call that test, and I need to choose a cluster group. That cluster group will eventually say which kind of policy will be applied on that cluster. So let's put it on the test cluster group. And I can also add labels, selectors, or description. I will do next. Now I need to decide which region I want to deploy on. In my case, it's going to be EU West 1, TMC Ireland. Which version of Kubernetes I want to deploy. I've told you can decide on earlier version, not just the latest and greatest. In my case, I will leave it like that. You can decide if you want to create that on a specific VPC or a new VPC. Let's leave it with a new VPC. And what's the CIDR of that services, of that VPC, sorry. Here you will configure the CIDR for pods and the CIDR for services internally in the cluster. Then you need to decide on the control plane, 1 or 3, depends on what you want to achieve. If you stay with 1, you can decide which type of EC2 machine do you want to provision. If you're going into 3, you can also change the availability zones, not just the instance type. In my case, I'm going to leave it 1. And now I'm getting to the same configuration pane of the node pools. So you can decide how many workers do you want and which kind of workers do you want. And that's it. You can actually add another node pool if you want. That's in that way you can actually mix and match different nodes in different clusters. I won't provision the cluster because it's taking too long. And I do want to show you how do I attach a cluster. And that's as easy as applying a YAML file on a Kubernetes cluster. So what I will have here is I'm going to change my context into a new cluster that I don't have Tanzu Mission Control on. That's one of my Kubernetes clusters. I will get namespaces. You see, I don't have any Tanzu Mission Control namespace. So I basically want to manage that cluster right now. I'm going to add that to my organization. I'm going to do attach a cluster. I'm going to call that TAS, that's Tanzu Application Service cluster. And I'm going to add that to cluster group dev. So let's do dev TKG Tanzu Application Service for Kubernetes. Now that cluster is going to be running from a vSphere environment, so it's not going to manage the lifecycle management of that. But the only thing that I need to do is basically copy that kubectl create command into my console, and that's going to run all the different configuration and will create all the different things that I need to basically configure Tanzu Mission Control on my cluster. And in a couple of minutes, you will see that that cluster is being connected and basically managed by Tanzu Mission Control. Let's see if there's any questions. If not, I will go over to policies. No questions. Okay, so in the meantime, while it's registering that dev TKG Tanzu Application Service for Kubernetes cluster, let's go over a little bit about policies. And to go to policies, I want to change my context of Kubernetes to my playground cluster, and that's the security cluster. So I have my security test cluster, and it's just the one that we've created the demo environment on. You see that 6 minutes ago, we've created that namespace. So the first thing is I want to delete the namespace. So I'm deleting the namespace demo because I don't know who created that and why, and I don't want anyone to touch my environment. if I will do a kubectl get namespaces again, I will see that the demo is back and it's 4 seconds. The way the Tanzu mission control is working is exactly like Kubernetes. There's intended state and there's a run state. And that intended state said that there should be a demo namespace inside of that cluster. And if I'm deleting that, it will create another one. So that's important thing to understand. The Tanzu mission control reconciling itself with policies and different environment objects. So let's go to policies. So in the policies view, I have two different constructs. As I said, one is the clusters, one is the workspace. Those two different constructs has different policies that you can apply on. And let's go to clusters. The first thing is we're going to apply an identity policy. So if I will do the security group, I can see there's no direct access policies. There's a lot of inherent cluster policies, and that's the basic one for the organization, but there's no direct policies for that group. Now, what I'm doing basically is I'm leveraging another user that I have, and that's the tanzudemos@gmail.com. So I'm connected with a different user, and as you can see, there's no access rights for that user to any cluster. Right now, it's an empty list. And what I'm going to do is I'm going to add the secured group access to that specific user. So I'm going to do create role binding. I can decide which kind of environment access does he have. Let's do it a cluster admin. And I'm just going to write tanzu.demos@gmail.com. Add. I'm editing that, create, and now that's it. When I'm going back, I can do a refresh and I will have access to that cluster. Now, that's just one cluster and it's just vSphere. So that doesn't impress anyone. So we will gonna do that on an organizational level. I want access to all of my cluster, regardless of which kind of infrastructure provider it is. And I want to do that in an organizational view. So I'm gonna do cluster admin the same, and I'm gonna do tanzu.demos@gmail.com. Add. And I'm gonna create that. So I've created an organizational access. So now when I'm going back, I will have access to all of my clusters. And that's across any infrastructure provider that I'm managing, any cluster. That specific function that I did in just 5 seconds is going to take a long time to manage with a lot of different other consoles when you do that across different clouds. So that's just one. The second thing about access policies is when you get into a specific cluster, you can see the direct access policies from the group. So you can see here, there's the access for tanzudemos.gmail.com. But you can also see unmanaged Kubernetes RBAC. So you can see all the different roles and role bindings that is inside that cluster. I'm hiding the Tanzu role and I'm hiding the system roles. So all of those different roles are not related to Tanzu or to the system. Those was created as part of an application running. In this case, a CNI, Calico, and the wavefront collector, that's observability. So you have a lot of visibility to understand what's going on. Now, in the same sense of visibility, I can go do security policy. Security policy will allow me to leverage that pod security policy aspect that I've mentioned before. So you can do allow running privilege, allow privilege escalation, and run as root or not. So right now it's a strict policy. I can also, of course, do custom and change everything, but I want to do that in a strict way. I want to apply the most stricted policy that I can, and I'm going to call that strict. Now, because I don't want the cluster to break, if anyone did something, if it's a cluster that I don't know, I don't want to affect anything. So I'm going to keep it strict, but I'm going to enable, switched on the disable policy enforcement. So I've applied the strict policy, but it's not really taking into effect. Why does it matter? Because now I can go to insights. Policy insights will allow me to understand what's going on with my cluster. And in policy insights, I can see that I have inside my security policy, I have one insight in the security that says, fail to create constrained server, could not find request resource. So I have something that is wrong with that cluster, with that security enforcement, And if I will run something like a pod security policy, or I will try to run a pod that needs root access or need escalation access, I will get the information about it, but it won't stop the run state of that workload. And that's really important if you want to do something that is, you want to assess the situation, but you don't want to stop. Now, the last demo that I will do will be on a workspace level. The workspace level, as I said, is more about the application construct. So if I will go to workloads, you can see I have different, not workloads, workspaces, sorry. I have different workspaces. One of them is the Nginx. The Nginx group will have different namespaces on different clusters: test, TKG, Kubernetes, security cluster, and AKS. Now, the policies that I'm applying on that will be applied on all those three namespaces. Now, I'm just gonna remind you that my security cluster has that Nginx namespace, and that we've created with Tanzu Mission Control. And right now, when I'm applying that policy, I'm basically applying that on that namespace. So let's apply a policy of Nginx of some sort. So I will go back to assignment of policies, workspaces, and Nginx. The first thing that I can do is access an identity, just like I did for cluster groups, but I want to do something that is more an application oriented, so I will do image registry. In this case, I'm saying to my development team, you have to pull images from harbor.tanzuworld.com. If you're not doing that, it should not run. So if I will go back to my cluster, and now I want to kube control, kubectl, run, let's say Nginx, let's call it Nginx, and the image will be Nginx in the namespace Nginx. So I'm trying to run a pod called Nginx, and I'm trying to pull the image Nginx that's gonna pull from Docker.io, and I'm trying to run that on the namespace Nginx. Now that doesn't work. Why that doesn't work? Because I have a policy violation that says that I can't pull from that source. From the other end, if I'm gonna change that image, right? Let's go to the policy. You see, I need to pull from my harbor.tanzuworld.com. So if I'm gonna change the image and I'm gonna add pull from my registry, harbor.tanzuworld.com /openso/nginx, that will run the pod. Now, that's exactly is how we can leverage the application side policies to get consistency across, different namespaces. And it's not just in that cluster. That's just one cluster out of three. So the workspace itself has three different namespaces on three different clusters. When I apply that policy, I've applied that across those three clusters. So that was Tanzu Mission Control in an hour. We are getting to the top of the hour, and I really want to leave some time to questions, remarks, and anything else, requests. I hope it was useful, and let me get to the questions. So, does it show any container information, any matrix status or latest? Oh, that's a great question, and I'm glad that I've left some time. So if I will go to one of my clusters, I can see here in the integrations that I have an integration to Tanzu Observability by Wavefront. I can now click on Actions, Tanzu Observability, and open Tanzu Observability. That will open a dashboard of that specific cluster and will allow me to understand a lot of different things about that cluster, up to the container level, not just the pod level. So I can see the active nodes, I can see the namespaces, the pods containers. I can go into different infrastructure matrix, I can go into different application matrix, so I can really understand what's going on inside a specific environment. Now that's from the bottom up. So you can actually go and check not just the Kubernetes side of things, but also the application side of things. Now I can get into a specific pod and see the CPU, the containers inside a specific pod, and I have different dashboards, so I can group by namespaces, and I can see according to a namespace what's going on. There's a lot of different things that you can see from observability perspective with Tanzu Observability and the integration to Tanzu Mission Control. When attaching a cluster, does TMC add any custom data to the YAML specific to TMC? I'm not sure that I understand the question. When you're attaching a cluster, and I've showed that before, it's basically gonna install all of those different extensions. So you know what? Let me show you that in the console. So if I will get pod in the namespace and VMware system TMC, those are the pods that is being installed. Now, those pods are exactly like, it's a reflection of that window where you have all the different capabilities and if it's healthy or not. Wavefront is not part of Tanzu Mission Control. Wavefront is now rebranded as Tanzu Observability, and it's a different cloud service in the same Tanzu Manage pillar. Any other questions? Because I can see that we are just on the top of the hour. Okay, so I think that we are finished for that session. I hope it was useful. I got the message around the build side, and I will create another session about the build. I hope that I will be able to deliver that soon about the VMware Tanzu build pillar. I hope it was useful around the Tanzu Manage. And what we saw basically is Tanzu Mission Control that take care of the operational side of the multi-cluster, multi-cloud environment, with all the capabilities of Tanzu Mission Control around policies, inspections, data protection, provisioning, lifecycle management, and so on and so forth. Thank you very much for the time. And I'll see you in the next time.